What's up, scholars? Today we're talking about conditional probability and independence. Our motivating question, are the events yes to taco tongue and yes evil eyebrow independent? Meaning, can they happen without, one happen without the other one? Well, let's find our class data from the previous lesson and fill in the two-way table. So, our last lesson we talked about who could do the taco tongue, who could do the evil eyebrow. And our table was as follows. We had 4 people that could do both. We had 4 people that could do the evil eyebrow but could not do the taco tongue, leading to a total number of people, 6 that could do the evil eyebrow. And we had 6 people that could do taco tongue but they could not do the evil eyebrow. We had 1 person that could do neither, so 7 total people were evil eyebrowless. There were 10 total people that could do the taco tongue. There were 3 total people that could not do the taco tongue, and both of these, 10 plus 3 is 13, 6 plus 7, 13. Alright, cool. So suppose we randomly choose a student from class. Find the probability that they can do the taco tongue or they could do the evil eyebrow. So to do that, we want to think about what or means here. Is it the Starbucks or, where we're including and, or is it not? And we need to take into account that we might be double counting people that fit into both categories. This is not the Starbucks or. So we need to subtract off the people that could be in both categories. So what is the probability that someone could do the taco tongue? That was 6 out of our total 13. 6 out of 13 people could do the taco tongue. How many people could do the evil eyebrow? I just said that backwards, didn't I? This column is the evil eyebrow. 6 out of 13 is the evil eyebrow. Okay, so now, how many people could do the taco tongue? That was 10. 10 out of 13. And how many people fit into both of those categories? 4. So we need to subtract that off so we're not double counting. So 6 plus 10 minus 4, 6 plus 10 is 16, minus 4 is 12. 12 out of 13 people could do the taco tongue or the evil eyebrow. Which makes sense, because we only had 1 person here that could do neither. So 12 out of 13 people were yes for one of the categories. Cool. Given that a person selected is yes evil eyebrow, we can lift. Can I do it? Yeah. I think hard enough. That can do the evil eyebrow. What is the probability that they are also yes to taco tongue? So, if we select a person that can do the evil eyebrow, we're in this category here. What is the probability that they can also do the taco tongue? We had 4 people that fit into both of those categories. 4 out of 13 people. That's our fractional representation. To do our decimo, I'm going to need a calculator, because I don't know what 4 divided by 13 is. Okay. 0.31, aka 31% probability that a random person selected can do the evil eyebrow and the taco tongue. How about question number 4? Given that a person is selected, given that this random person is selected, is no to the evil eyebrow, meaning they cannot do evil eyebrow, what's the probability that they are able to do the taco tongue? So here's our column of non-evil eyebrows, and here's our number of people that could not do the evil eyebrow but could do the taco tongue. So 6 out of 13 is the probability that a random person would fall into this category. There's our fraction. Let's do our decimal action. 6 divided by 13 is 0.46, or 46% of the time I choose a random person in class. They will not be able to do the evil eyebrow, but they will be able to taco tongue. All right. What we just described right there are conditional probabilities. These are conditional probabilities. Okay. These are conditional probabilities. We picked a category, and then we picked another category. So the number of people that fall into that second category is contingent upon the number of people that fall into the first category. Same thing here. We picked no evil eyebrow, and yes taco tongue. So the number of people in this category was conditional upon the number of people in the first category, right? We were asking the same question. What's the probability that they could do the taco tongue? But we got different answers because we had a condition under which we were asking that question. And we have a special way we're going to write those conditional probabilities. This one, where it says yes to evil eyebrow and yes to taco tongue, would be the probability of getting a yes taco tongue given that we got a yes evil eyebrow. So we're going to say yes taco tongue given yes evil eyebrow. Alright, so our probability for the second one would be the probability that we got a no for the, back it up, back in. The probability that we got yes for taco tongue given, that says yes, it's a very tiny yes, but it says yes. The probability that we get yes for taco tongue given we had no for evil eyebrow. Alright, so the first part is, what we're actually looking for, what's the probability that you get yes taco tongue. And the second part is what you are given originally. So the condition under which you are looking for that probability. Okay, here's the definition. Two events are independent if knowing whether or not one has occurred does not change the probability that the other event will occur. So in question 5, are the events yes taco tongue and yes evil eyebrow independent? Well, no. We got different answers here for yes taco tongue based off of our evil eyebrow abilities. Also, in our class, if you were able to do the evil eyebrow, you are more likely to also be yes for taco tongue. So no, these are not independent. No. A student who can do the taco tongue, who can taco their tongue, is more likely to be able to evil eyebrow. Evil eyebrow. Alright, whoops, cut you off there. A student who can do the taco tongue is more likely to be able to evil their eyebrows. Alright, let's keep on cruising on. Let's consider some data for all of ICS, Indianapolis Classical Schools. So in all of Heron and Riverside combined, we've got some information here. Cool. So we're going to use this chart to find each of the following using the data above. Right, as a fraction, decimal, and a percent. I'm going to let you do these ones because I'm pretty sure you can read this chart. Cool. You'll do those and show me. Wunderbar. Wunderbar. So let's write out our definition of conditional probability. Using our special format, we've got the probability of A given that B happens, aka just the words I just said, the probability. Probability that A happens given that B already happened. Cool. Now we talked a little bit about independent events already, so let's formalize our definition here. So for independent events, knowing that one event has occurred does not change the probability that the other event will occur. Knowing that one event has occurred does not change the probability that the other event will occur. So we can say that if the probability of A given B is the same as the probability of A given B complement, so the probability that A happened given that B happened, or the probability that A happened given that not B happened, anything else happened, those are the same things. That means A doesn't depend on B. That means the events are independent. Then independent. Okay. However, if that's not true, if the probability of A given B does not equal the probability of A given B complement, then it's not independent. That means that A really does depend on B. The probability of A happening depends on whether B happened. Not independent. All right, cool. Y'all are doing great. Let's keep on keeping on. Ooh, look at this good time. You're about to have a U-try problem. So this sounds like a you problem that you're going to do. And show me when you come to class next time. Oh yeah. Alright, this is the end of video number 1. We'll be back with video number 2. Keep it up, scholars. Keep on that hustle.